Hello everyone. Today we will going to see some practice questions from the topic chemical kinetics, and this is part 1. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. So this is the index slide, and today we will going to see some practice questions from question number 1 to question number 8. Let's start with the question number 1. A drop of solution, volume is 0.05 milliliter, contains 6 times 10 to the power minus 7 mole of H positive ion. If the rate of disappearance of H positive is 6 times 10 to the power 5 mole liter inverse second inverse, how long will it take for the H positive in the drop to disappear? We have to calculate the time which H positive ion take to disappear in the drop. Options are 8 times 10 to the power minus 8 second, 2 times 10 to the power minus 8 second, 6 times 10 to the power minus 6 second, or 2 times 10 to the power minus 2 second. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option B, that is 2 times 10 to the power minus 8 second. So, if we want to calculate the H positive concentration, H positive ion concentration, it will be the number of moles divided by the volume of the solution, right? Number of moles is given, that is 6 times 10 to the power minus 7 moles, and divided by the volume. Volume is also given, which is 0.05 per liter. So we convert it into liters. For that, we divide it by 1000. So 0.05 times 10 to the power minus 3 liter. So H positive concentration on solving this fraction is coming out as 1.2 times 10 to the power minus 2 molar. Now, the rate will be equal to del X by del T. Okay, this is the general formula for the rate of the reaction. Or you can say that del T is equal to del X by rate. Del X is change in concentration, which is the rate of disappearance of H positive is given, that is 6 times 10 to the power 5 mole liter inverse second inverse. So del X will be 1.2 times 10 to the power minus 2 mole, because we just have calculated the concentration of the H positive ion, right? So we just put the change in concentration as this concentration and divided by rate. Rate is given, the rate of disappearance is this much. So we divide it by this. Now on solving this fraction, it will be equal to the T time, so which is coming out as 2 times 10 to the power minus 8 second. Okay. Thus our option B is the correct answer. Okay, let's move to the next question. Question number 2. The instantaneous rate of disappearance of MnO4 negative ion in the following reaction is 4.56 times 10 to the power minus 3 mole per second. Reaction is 2 MnO4 negative plus 10 I negative plus 16 H positive, giving 2 Mn2 positive plus 5 I2 plus 8 H2. We have to calculate the rate of appearance of I2, because I2 is appearing in the product, right? So MnO4 minus is disappearing and I2 is appearing. Rate of disappearing of MnO4 minus is given. We have to calculate the rate of appearance of I2 molecule. Options are 4.56 times 10 to the power minus 4 molar per second, 1.14 times 10 to the power minus 2 molar per second, 1.14 times 10 to the power minus 3 molar per second, or 5.7 times 10 to the power minus 3 molar per second. You have 10 seconds to solve this question. After that, we will see what will be the correct answer. Okay. Let's see. The correct answer is option B, that is 1.14 times 10 to the power minus 2 molar per second. So rate of reaction, if we calculate the rate of reaction for this reaction given in the question, it will be minus half d of concentration of MnO4 minus divided by dt will be equal to 1 by 5 of d of I2 concentration divided by dt. Right? Because we just want these two things. We have given the value of this and we have to find out the value of this. Right? Therefore, the given rate of disappearance of MnO4 negative, that is minus d of MnO4 negative by dt. This we have given, which is equals to 4.56 times 10 to the power minus 3 molar per second. Right? So there, since therefore rate of appearance of I2 will be 5 by 2, because we have given this amount. So we have this. So, and we have to calculate this much, the rate of appearance of I2 molecule. So it will be 5 will come here in the numerator. So 5 by 2 times 4.56 times 10 to the power minus 3, which is equals to 11.4 times 10 to the power minus 3, which is equals to 1.14 times 10 to the power minus 2 mole per second. Okay. And this will be the correct answer. Thus, B option is the correct one. Okay, now let's see the question number 3rd. The rate law for the reaction RCl plus NaOH giving us ROH plus NaCl is given by rate is equals to K times concentration of RCl. The rate of the reaction will be, so we have given some effects on decreasing or increasing the concentration of something. So we have to tell that what will be the effect on the rate of the reaction will be. Options are doubled on doubling the concentration of sodium hydroxide, halved on reducing the concentration of alkyl halide to 1/2, decreased on increasing the temperature of the reaction, or unaffected by increasing the temperature of the reaction. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay. Let's see. The correct answer is option B, that is halved on reducing the concentration of alkyl halide to 1/2. So, as in the question only, the rate is defined as K times RCl concentration. Right? That means rate will only depend on the concentration of RCl, none other the reactants or the products. That means that on decreasing the concentration of RCl to half, the rate will also be halved because they are directly related. Other than that, if increase, decrease, anything, any other concentration of the reactants or products, it will not get affected. Okay. Thus, our B option is the correct answer. That is halved on reducing the concentration of alkyl halide to 1/2. Okay. Okay, let's move to the next question. Question number 4. The units of second order rate constant is. So we have reactions of first order, second order, right? So the second order rate constant unit we have to find out. Options are mole per decimeter cubic second inverse, decimeter cubic per mole per second, or none of these. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option C, that is decimeter cubic per mole per second. For the second order, we know this concept that dx by dt, that is rate, is equals to K time rate constant in times concentration to the power 2. That is whole square of concentration. This is the rate equation for the second order reaction. We have to find out the unit for the rate constant, that is K. It will be K is equals to dx by dt, and this concentration square will come in the denominator. So concentration by time, dx is what? Change in the concentration. So that unit will be of concentration here, right? So we take concentration divided by the change in time. So unit will be of time. So divided by time. Multiply by this concentration square comes in the denominator. So multiply by 1 upon concentration whole square. Now, one concentration term will cancel out and the 1 will remain in the denominator. So if we write it in the numerator, it will be concentration to the power minus 1. And time will also in denominator. So it will also, the power will also be minus 1 for the time as it comes into the numerator. So K unit, that is rate constant unit, will become for the concentration decimeter cubic. For the time, it will be second, right? So for the concentration units is, concentration is basically molarity. Molarity is number of moles upon the volume. If you find out the concentration unit, it will be mole per decimeter cubic in the terms of decimeter, right? Moles per decimeter cubic. That means mole to the power 1, decimeter to the power minus 3. But it's already, the concentration is in power minus 1. So the minus will become plus, plus will become minus. So mole power plus 1 will become mole power minus 1. Decimeter power minus 3 will become decimeter power plus 3. And time is second. So it will be second in moles. So final rate constant unit is coming out as decimeter cubic per mole per second. And the C option is the correct answer. Okay, let's move to the next question, question number 5. For the reaction system 2NO plus O2 giving us 2NO2, volume is suddenly reduced to half its value by increasing the pressure on it. Okay, so volume is reduced to half of its value and pressure is increasing. If the reaction is of first order, it is given that reaction is of first order with respect to O2 and of second order with respect to NO, nitric oxide. The rate of reaction will be. So what will be the effect on the rate of reaction then? Options are diminish to 1/4 of its initial value, diminish to 1/8 of its initial value, increase to 8 times of its initial value, or increase to 4 times of its initial value. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option C, that is increase to 8 times of its initial value. If you write the rate expression, it will be dx by dt is equals to K times NO whole square O2, right? We write this with the use of this reaction system given in the question. NO whole square because 2 is the stoichiometric coefficient present with the NO in the reaction, and O2 will be coming out as O2 because no stoichiometric coefficient is present. It is 1, so basically power will be 1, and the reaction equation will be this. So how to calculate the concentration of NO? We just simplify it. It will be K times number of moles of NO whole square divided by volume whole square, because NO concentration is in whole square. So this is the concentration formula, number of moles divided by volume, and the power will become 2 for both number of moles and volume, multiplied by the O2 concentration, which is number of moles of O2 divided by the volume. Now dx by dt is equals to K upon V will be V cube, 2 plus 1 cube, K upon V cube, number of moles of NO whole square times number of moles of O2. Now, what it is said in the question that the new rate we have to find out for which we reduced the volume to the half of its initial value. So V will become V by 2. So dx by dt prime new rate is equals to K of number of moles of NO whole square, number of moles of O2 divided by V will become V by 2. So V by 2 whole cube. Right? 2 to the power 3. 2 cube will be 8. And as it is in here, so it will come here in the numerator, in the multiple. So it is equal to 8 times of dx by dt, because dx by dt is this much. So if we take 8 here, the rest is nothing but dx by dt. Right? So we can write it as 8 times dx by dt. So you can see clearly that the new rate increases to the 8 times of the initial value of the rate. And thus C option is the correct answer. Okay, let's move to the next question. Question number 6. For the non-stoichiometric reaction 2A plus B giving us C plus D, the following kinetic data were obtained in 3 separate experiments, all at 298 Kelvin. We have a data given in the table form here by doing the 3 separate experiments for this reaction. So initial concentration of A is initially it is 0.1. For the initial concentration of B, it is 0.1. The initial rate of formation of C is coming out as 1.2 times 10 to the power minus 3 mole later inverse, second inverse. Then we take the initial concentration of A as 0.1 molar, B as 0.2 molar, and the rate of formation of C is 1.2 times 10 to the power minus 3. Now, in the third experiment, we take the initial concentration of A as 0.2 molar, initial concentration of B as 0.1 molar, and the initial rate of formation of C is coming out as 2.4 times 10 to the power minus 9 mole per liter per second. We have to tell the rate law for the formation of C. The rate law expression for the formation of C will be. Okay. Options are dC by dt is equals to K times concentration of A times concentration of B. dC by dt is equals to K times concentration of A square times concentration of B. dC by dt is equals to K times concentration of A times concentration of B square. Or dC by dt is equals to K times concentration of A. You have 10 seconds to solve this question. After that, we will see the answer. Okay. Let's see. The correct answer is option D. That is dC by dt is equals to K times A. So you can write the rate expression for the formation of C as dC by dt is equals to K times concentration of A power X, concentration of B power Y. Okay. Because we have experimented 3 times. So we have to find out what will be X and Y. Okay. So now what we will do, we just write this rate equation and put the values given in the tabular form in the question. So initial rate is given 1.2 times 10 to the power minus 3 is equals to K times A concentration is 0.1, B concentration is 0.1. Let's suppose this is fast reaction. First equation. In the second information, it is given that rate will be 1.2 times 10 to the power minus 3 is equals to K times A concentration is 0.1, B concentration is 0.2. Let's suppose this is second equation. Similarly, in the third reaction experiment, in the third information in the tabular, it is given that rate is 2.4 times 10 to the power minus 9 is equals to K times A concentration is 0.2 power X, B concentration is 0.1 power Y. Let's suppose this is third equation. So as shown, you can see that the rate of reaction remains constant as the concentration of reactant B changes from 0.1 molar to 0.2 molar. So if you see in the first and the second equation, this is third. Okay, let me write again. So you can see in the first and second equation that If you change the concentration of B from 0.1 to 0.2, there is no effect on the rate of the reaction. The value is same. But it becomes double when the concentration of A changes from 0.1 to 0.2. Right? When the concentration of A, you see in the second equation, the third, if the concentration of A becomes 0.1 to 0.2, the rate of the reaction will also change. So that means the formation of C depends on the concentration of A, then the concentration of B. So therefore you can write that R is equals to K times A concentration power 1, B concentration power 0, because it does not depend on the concentration of B. Okay, and thus our D option is the correct answer. Okay, let's see the next question. Question number 7. Consider a reaction Ag plus BH giving us products. When concentration of both the reactants G and H is doubled, the rate increases by 8 times. However, when the concentration of G is doubled and keeping the concentration of H fixed, the rate is doubled. The overall order of the reaction is. Order we have to find out. Options are 0, 1, 2 or 3. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option B. So this is the reaction given Ag plus BH giving us products. Let's suppose the rate of reaction be this. R is equals to K times G to the power A, H to the power B. Right? When the concentration of both reactants G and H is doubled, it is given that rate increased by 8 times. So you can write as 8R is equals to K times 2G power A, 2H power B. Because it is given that if you increase the concentration, if you double the concentration of reactant G and H, the rate becomes 8 times. Right? So let's suppose this is the second equation. Now, it is also given that when the concentration of G is doubled and the concentration of H remains fixed, that is 2G and H, the rate is doubled. That means 2R is equals to K times 2G power A, H power B. Okay, so H is fixed, G is doubled, rate will be doubled. Let's suppose this is third equation. Now we just observe between the second and the third equation. So from second and the third equation, we can calculate that B is coming out as 2. Now, if you put B is equals to 2, so in the equation third, and on solving equation first and equation third, you can calculate that A will coming out as equal to 1. Right? So this is the order, right? Sum of A and B is the order. So overall order of the reaction will be A plus B, because they are the stoichiometric coefficient, or they are the power of the concentration in the rate law. So A is 1, B is 2, so 1 plus 2 is equals to 3, and thus the overall order of the rate of the reaction is 3. Thus D option is the correct answer. Okay, moving to the next question, question number 8. At 518 degrees Celsius, the rate of decomposition of a sample of gases acetaldehyde initially at a pressure of 363 torr was 1 torr per second when 5% had reacted, and it is 0.5 torr per second when 33% had reacted. So you have to tell the order of the reaction. Options are 2, 3, 1 or 0. So you have 10 seconds to solve this question. After that, we will see the correct answer. Okay. Let's see the correct answer. The correct answer is option A, that is 2. So as per the given question, the reaction will be acetaldehyde decomposed to methane plus carbon monoxide. Okay. Now let the order of the reaction with respect to the acetaldehyde is M. Okay. It is given that the rate 1 is 1 torr per second when the acetaldehyde is 5% reacted. What it means? It means that 95% is unreacted. Similarly, it is also given that the second rate is 0.5 torr per second when CH3CHO acetaldehyde is 33% reacted. That means 67% unreacted. Okay. So we just use the formula that rate is directly related to the unreacted concentration whole power n. Okay, so A minus X is an amount unreacted. You can also say that amount reacted. We can also write that. Okay. So rate is directly related to the amount unreacted whole power m. M is the order. Now we just write the rate equation. We just use the rate equation for both the process. When 5% is reacted, 95% unreacted, and when 30%, 33% reacted and 67% unreacted. Okay. So we can write it as R1 by R2 is equals to A minus X1 whole power m upon A minus X2 whole power m. Okay. Or simply you can write it as R1 by R2 is equals to A minus X1 upon A minus X2. Now let's put the value. Rate 1 is 1 when the amount unreacted is 0.95, 95%. And R2, that is rate 2, is 0.5 when the amount unreacted is 67%, that is 0.67. Okay. So this side it will be 2 and this fraction will be 1.4. Whole power m as it is present initially, because m is the order, we have to consider that. So whole power m, and if you solve this, if you put m is equals to 2, it come out as 1.9 something, which is equivalent to 2, right? So you can say that m is equals to 2, and therefore the order of the reaction is 2, and this we have to find out. Thus the A option, that is 2, is the correct answer. Okay. Okay. Thank you.